This model portrays a universe that expands relative to the observer. And this is, in a literal sense, a model of quantum gravity, since space-time itself is quantized relative to the observer. In this way, the most fundamental problem in physics, unifying quantum mechanics and space-time, is resolved with two propositions: that the universe expands relative to the observer, and there are multiple observers. Consider these 5 purple galaxies. As time passes and the universe expands, the red galaxy recedes along a direct line of sight away from each of them. If we could set up a detector in the cosmos and run an experiment from a God's eye point of view, we would see every possible location of the red galaxy hit the detector like a wave. Now let's alter the experiment by placing a barrier with 2 slits in front of the red galaxy. And let's run this experiment from the perspective of the purple galaxy in the middle. As time passes and the universe expands, observers in the purple galaxy would see the red galaxy pass through one of the 2 slits, and it would hit the detector like an object, not like a wave. Now let's run the experiment again, only this time let's remove the observer. This experiment is now unfolding behind the scenes. Without running this experiment from anyone's point of view, this experiment is now unfolding from a God's eye point of view, in a realm of possibility, where the perspectives of all observers who might tune into this experiment are accounted for. As time passes and the universe expands, the possible locations of the red galaxy hit the barrier like a wave. To summarize, in the terms of this model, the collapsed wave function is a personal universe, while the wave function itself is the shared universe, the community of personal universes. In this way, the double-slit experiment, the classic demonstration of the mystery of quantum mechanics and the wave-particle duality of matter, is explained by this model, by personal universes coexisting in the shared universe. Let's take a closer look at this explanation. Observers in these 5 galaxies each have personal universes that expand relative to them alone. As time passes, each sees every other galaxy recede 1 unit of distance in 1 unit of time. Let's look at what happened to the red galaxy. After 1 unit of time, the red galaxy exists in 4 different locations, depending on the observer. From the perspective of observers in the black galaxy, the red galaxy began 4 units of distance away. After 1 unit of time, the red galaxy diffracted into 4 possible locations. So, as the universe expands, the red galaxy diffracts into many possible locations on this waveline. As a rule, once we determine the momentum of the red galaxy, the line on which it recedes, we necessarily become uncertain about its position. To know the momentum of the red galaxy in our personal universe is to be uncertain of its position in the shared universe. On the other hand, once we determine the position of the red galaxy, we necessarily become uncertain about its momentum. The red galaxy could be receding along any line of sight in any direction, depending on the observer. To know the position of the red galaxy in our personal universe is to be uncertain of its momentum in the shared universe. Notice how the uncertainty principle, the foundational tenet of quantum mechanics, which is itself unexplained by quantum mechanics, emerges in this model out of 2 basic propositions: that the universe expands relative to the observer, and there are multiple observers. Now let's apply these basic propositions to the biggest problem of modern cosmology: dark energy. In these diagrams, observable universes will grow at the speed of light in this otherwise static cosmos. As in reality, all observers with the same horizon distance are simultaneous to each other relative to the Big Bang. Let's set the horizon distance of this universe to 5 billion light-years. Now let's run the clock forward 1 billion years. The horizons of the blue and green galaxies now overlap 2 billion light-years at their apex. In fact, every observer that is 5 billion light-years away from the black galaxy now has a horizon distance that extends 1 billion light-years beyond the black galaxy. If they were all accounted for, their overlapping horizons would form a complete circle around the black galaxy, with a radius of 1 billion light-years. This shaded circle represents a new force of negative pressure in this universe. When two personal universes overlap and expand in opposite directions, they push against each other in the shared universe, which creates a region of negative pressure in between them. Negative pressure pulls together, like a stretched-out spring that snaps back in. However, when different regions of negative pressure interact, their inward pulling energies compete with each other, which pulls the space between them in opposite directions and generates a repulsive effect. And since different observable universes are overlapping everywhere, a repulsive force is evenly spread across the entire cosmos. In this way, dark energy is a natural outcome of different personal universes coexisting in the shared universe. At the same time, in a universe that expands relative to the observer, pressure is exerted back upon the observer's galaxy from every direction, which generates an extra-gravitational effect that holds the galaxy together. Let's take a closer look at this effect. In this image of the bullet cluster, which is actually two clusters that have recently passed through each other, the galaxies are highlighted in blue, and gas is highlighted in pink. When two clusters pass through each other, the galaxies in each of them are unlikely to collide. But in a typical cluster, the bulk of the matter is actually found between the galaxies in the form of diffuse gas, and this gas is bound to collide when two clusters pass through each other. That's what happened here, and as a result, the gas in each respective cluster was displaced. It now floats in between the two clusters themselves, and this should be the place where gravity is the strongest, since the bulk of the matter is found in the gas. But that is not what we observe. The force of gravity is not displaced along with the gas. Instead, it remains centered on the galaxies themselves. In the context of this model, since the universe is not expanding relative to the cloud of gas, since no observers are there is also no pressure exerted back upon that region from every direction, which is happening around the galaxies, where most of the gravity therefore remains. In this way, so-called dark matter is a natural outcome of two basic propositions: that the universe expands relative to the observer, and there are multiple observers. Consider another outcome of these basic propositions. As personal universes overlap with each other in the shared universe, they push against each other and through each other. The purple shaded section represents the amount of negative pressure generated by this interaction, pushing against each other, while the red shaded section represents the amount of positive pressure generated by this interaction, pushing through each other. These two opposing forces cancel each other out, and what remains is a leftover amount of positive pressure. These two personal universes are pushing through each other slightly more than they are against each other. This happens all over the cosmos, with interactions between different personal universes yielding different amounts of positive or negative pressure. At any given time, the sum total of these interactions cancels itself out almost, but not quite, completely. So a huge amount of vacuum energy, 10 to the 112 ergs per centimeter cubed, is reduced to a tiny, non-zero amount of leftover energy, 10 to the minus 8 ergs per centimeter cubed, which accounts for the gradual expansion of our universe. The physics community is, at present, fundamentally unable to explain this vast discrepancy between the energy and the behavior of the vacuum of space. But in the context of this model, the vacuum catastrophe is straightforwardly resolved by a universe that expands relative to the observer. Another one of the biggest puzzles of modern physics is the fact that there are 3 different copies of matter in the universe. This mystery is so deep that the physics community does not even have a standard hypothesis to explain it. So let's continue with our approach and resolve this problem by considering the expansion behavior of the universe. Here is the earliest evidence of dark energy, The stuff we call dark energy was relatively weak, but starting to make its presence felt 9 billion years ago. About 5 billion years ago, this expanding force grew so powerful that it pushed the universe into a new phase of accelerating expansion. Notice how the history of the cosmos is roughly divided into thirds, a congruence that the physics community has never recognized. Furthermore, notice how the universe is, at present, composed of roughly 2/3 dark energy, the same ratio of dark energy's observed existence in cosmic time, another congruence that the physics community has never recognized. I propose that we take these congruences seriously as pointers toward an intracyclic model of cosmology, where the universe switches phases at regular intervals, both in the way that space expands and in the way that matter is structured over time. In this way, the 3 generations of matter are explained by this model. Let's take a closer look at this explanation by using it to solve another mystery of modern physics, the asymmetry between matter and antimatter in the universe. The Big Bang should have created these 2 types of matter with opposite charges in equal amounts. But everything we see today is made almost entirely of matter. There are 2 standard hypotheses to explain this asymmetry. The first is that matter and antimatter are asymmetrical in structure. In 2017, the magnetic properties of the antiproton were measured with, as yet, unparalleled precision. Scientists then compared these properties to the proton and found no discrepancy between them. All of our observations find a complete symmetry between matter and antimatter. An asymmetry must exist somewhere, but we simply do not understand where the difference is. The second hypothesis is that matter and antimatter are asymmetrical in space. Matter and antimatter need to be separated from each other to prevent their mutual annihilation. If certain galaxy clusters within our observable universe were made of antimatter, then there would be immense gamma radiation coming from the boundary regions between clusters of different types. At present, such radiation is not observed, a fact that argues against this separation. If we accept what appears to be true, that matter and antimatter are not asymmetrical in structure or in space, only one other explanation naturally comes to mind: that they are asymmetrical in time. This means that the balance of charge in every atom in the universe switches at regular intervals throughout the entire cosmos, all at once. And a single theoretical framework describes the way that space expands, the way that matter is structured over time, and the way that charge is balanced in every atom in the universe. The game of fundamental physics is to derive as much as possible from the fewest and simplest propositions. The ultimate measure of success is whether a single model can respond to the various problems of the field. The reason there is a crisis in physics is because, in today's models of the universe, all of these problems stand in isolation. They are all mysteries unto themselves and disconnected from each other. The physics community is, at present, fundamentally unable to unify these mysteries into a single theoretical framework. But in this model, rather than one-off guesses at the nature of reality, the solutions to these problems are embedded in a common system. Each explanation reinforces the others. In this way, all the major problems of modern cosmology and the crisis in physics are resolved by this model, a ridiculous theory of dark energy, including the flatness problem, the horizon problem, the axis of evil, and dark flow.